Okay, so if you are watching this video, that means you want to know the reason why limit of sine x over x as x approaches to 0 equals 1, right? In our class, we did a calculator approach to that, but that doesn't always make sense. So I want to show you a geometrical proof behind why the limit of sine x over x as x approaches to 0 equals 1. So here, as you can see, I have a pizza slice. And this is not just a pizza slice. This is a sector where the radius is 1 and the angle is x. And I'm going to define that this angle is not in degrees. Because starting from pre-calc, we want to use the angle as radians. So I'm going to define that this angle, x is between 0 and pi over 2 in the first quadrant. And by having that in mind, look at what I'm going to do. I am going to make a perpendicular line starting from this point A, and I'm going to mark this point C. And I have a red triangle of OAC. Do you guys see that? And what I'm gonna do next is to extend this line OA until I get a big blue triangle of ODB. So here I have shown you two similar right triangles. The red one, OAC, and the blue triangle, ODB. I know it looks kind of cranky, human error, but it's gonna be a right triangle right here. Let me draw the angle for you guys. Now, here I want to show you something. Let's say this red triangle OAC is a right triangle and the hypotenuse is a length of 1 because it's based on this radius, so it should be 1. Then, what is the length of AC and OC? By the definition of trigonometry, and if you already know that the angle here is x, it should be automatic for you guys that the length of the opposite AC is sine of x, and the adjacent length is going to be cosine of x. Now, I know all the length of these three sides of the red triangle. But what about the big blue triangle ODB, where the angle is still same as x? This time, my hypotenuse is not 1 because it's longer than 1, as you can see from the picture. But what is the length of OB? OB is 1 because because radius is the same length. If the radius is 1 over here, the radius OB is also 1 by the definition of circles. So my OB is 1. Then what is the length of BD? Well, the length of BD, you guys can use the idea of similar triangles. For example, from cosine x to 1, I can say if the length OC is cosine x, the corresponding side is 1. That should equal the length of AC sine x over the mystery side BD. All we have to do now is cross multiply this two, and we are going to get the conclusion that the length of BD equals sine of x over cosine of x. And what is sine x over cosine of x? Tangent of x. So it's going to be tangent of x. Therefore, I can say the length of BD is tangent of x. Okay, now I have two triangles, and so what? Like, why did I even like drew these two triangles and made it up? The reason why is because now we are going to compare the areas of the red triangle, the pizza slice, the sector, and the big blue triangles. So I can say that, oh, let me move this to this side so you guys can see it much more nicely and thorough. I can say the area of the triangle OAC and the area of the big triangle, oh good lords, my bad. Triangle, oh good lords. Triangle of ODB, they are squeezing the area of this sector, area of OAB, the sector. Well, why? Because look at the drawing, it's obvious. The red triangle area should be smaller or equal than the sector area, but the blue triangle is going to be greater area or equal to the pizza slice. So I can set it up like this. Now, before we move on, everybody should know the area of a triangle, right? Like 1/2 times the length times height. But do you guys remember the area of a sector from geometry class? Let's review that real quick. The area of the sector is the angle over total angle multiplied by pi r squared. This angle over total angle represents the ratio, and this pi r squared represents the area of the circle itself. What is my angle of this sector? Is x, right? So my area, or not the area, the angle of this sector is x. What is the total angle of this whole entire of all these four quadrants combined? What is the total angle of a circle? If you say 360, you are stuck in the past. Starting from pre-calc, we are not using degrees, we are using radians. So what is my 360 degrees into radians angle? 2 pi. So my total angle will be 2 pi. And what is my radius? 1. What is 1 square? 1. So it's going to be pi. Now, you guys see that x over 2 pi times pi can be simplified? You can cross out those 2 pi's and you're only, oh good lords, you're only left with x over 2. Okay, now let's go over the area of the red triangle OAC. 1/2 multiplied by the length cosine x by the height sine x. And what is the area of the blue triangle? 1/2 multiplied by the length 1 multiplied by the height tangent x. Now, we have set up this wordy notation into a mathematical notation, and the magic is gonna happen now. Stay tuned. So, I can see that everything is multiplied by 1/2. That means I can multiply positive 2 on all my inequality. So I'm only left with, oh good lords, I have to write it color so you guys can see where's everything coming from. And this is cosine x sine. All I did is just multiply number 2 on all my inequalities. Now look at what I'm gonna do. Here, I'm going to divide all my inequality by sine x. Like this. Is this possible? Like, Is this possible? Because sometimes there should be an x value where it makes sine x equal 0. And if sine x equals 0, I cannot divide sine x. There is no problem actually. I can divide by sine x because sine x cannot be a 0. Do you know why? Look at my first statement. Oh, x is an angle value of radius where it's greater than 0, less than pi over 2. Between those radian value, sine x cannot equal 0. So I can divide sine x. And if I do that, what happens? Gosh. Sine x and sine x is going to get canceled out. So I only left with cosine x on the left. And I just have x over sine x. And here, tangent x over sine x. Do you guys remember that tangent x equals to sine x over cosine x? So I can say tangent x over sine x can be simplified into 1 over cosine x. Should have written that in blue, my bad. Just a minute. Okay, so now I have a conclusion of saying x over sine x is greater than or equal to cosine x, but less than or equal to 1 over cosine x. So what? Like, what are we doing next? Now, I want to flip everything by the reciprocal. I'm gonna flip everything by as a reciprocal. And am I allowed to do that in the mathematical way? Yes. It's not gonna stop you unless you guys flip the signs. Now, sin x over x. We have finally reached sin x over x. But is sin x over x what we're looking for? No. We are looking for the value of the limit of sin x over x when x approaches to 0. Now, if I put a limit notation in one of the inequalities, then by the rule of inequalities, I have to put that limit, the exact same limit where x is approaching to both of the inequality. That makes my inequality still true. So I'm going to write down the limits and voila, I have a limit inequality. Now, what I'm gonna do, actually it's the easy part. I'm gonna substitute where the x is approaching. And we already have done that in class, right? The substitution, like solving in limits. Here, if I substitute 0 inside my 1 over cosine x, what does it equal to? Cosine 0 equals 1, so therefore, it's gonna be 1. What about limit of cosine x as x approaches 0? Cosine 0 is 1, so this is also 1. Wait a minute. That means my limit of sine x over x as x approaches to 0 is a value where it is less than or equal to 1, but greater than or equal to 1. Then what is the only value that satisfies this limit? Therefore, limit as sine x over x as x approaches 0 equals 1. Because if a certain value is like less than or equal to or greater than equal to the exact same number, then by the rule of inequalities, it's just that value. It equals that value. And that is the only value that satisfies my inequality. So before I close this video, this is the geometrical proof why limit of sine x over x as x approaches to 0 equals 1 by geometrical proof. By comparing two area of triangles and squeezing it through. The reason why this proof is useful because in the future you'll be learning squeeze theorem maybe in calculus, and this is one example why how to use it. And second, this limit value, limit as sine x over x as x approaches to 0 equals 1, this comes out very often throughout our year in calculus BC. So do not just memorize it, understand it. This is the end of the video, and I wish everybody now know the reason why that is that. Thank you. How do I stop?